Junior High School Math, based on the Japanese textbook, revised in 2025. In this course, mathematics, taught in Japanese junior high schools, is explained in English. It is designed for Japanese students who are considering studying abroad. But by using subtitles, it can be viewed and understood in any language around the world. Chapter 1. Expanding the world of numbers. A factor is a number that can divide another number exactly. By exactly, it means with no remainder. 12 is 2 times 2 times 3, so its factors are 2 and 3. Of course, factors include 1 and itself. A multiple is a number that you get by multiplying another number by whole numbers. For example, 4 times 2 equals 8. 4 times 3 equals 12. So you can say 8 and 12 are multiples of 4. Of course, 16 is also a multiple of 4. Then let's check common factor and common multiple here. Common factor is a factor of 2 or more numbers. For example, 8 equals 2 times 2 times 2. 12 is 2 times 2 times 3. That means 8 and 12 has 2 as a common factor. You can also say they have 4 as a common factor. Common multiple is a number that 2 or more numbers share among their multiples. For example, 4 times 9 equals 36. 3 times 12 equals 36. As you can see, 36 is a multiple of 4, and it's also a multiple of 3. Then you can say 36 is a common multiple of 4 and 3. Finally, it's GCF and LCM, which are greatest common factor and least common multiple. The former is the largest number that divides 2 or more numbers exactly. 2 is a common factor of 8 and 12. But 2 times 2, which is 4, is larger than 2, and no larger common factor here. That means 4 is the greatest common factor of 8 and 12. The latter is the smallest common multiple of 2 or more numbers. 8 times 6 equals 48. 12 times 4 equals 48. So you can say 48 is a common multiple of 8 and 12. But there is a smaller common multiple. For example, 8 times 3 is 24. 12 times 2, 24. 24 is smaller than 48. No smaller multiple of 8 and 12 here. So 24 is the least common multiple of 8 and 12. There is one more thing that you should keep in mind when you multiply GCF and LCM. In this case, GCF 4 times LCM 12 equals 96. It equals the product of first two numbers, which are 8 and 12. You can check if your calculations are correct using this property.
Here, we are going to talk about how we can find GCF of two numbers. You probably learned this method in elementary school. First, you lay out all the factors of each number on the list. Since we didn't learn factorization in elementary school, we had to find the greatest common factor by listing the divisors. Then we had to rely solely on our own calculation skills. But now you know how to factorize numbers. So let's see how you can find factors of each number. For 18, you can immediately say that 1 and 8 are factors. 18 has 2 and 3 as factors. And 2 times 3 equals 6. So 6 is also a factor. 18 has 2 3's when it's factorized. So 3 times 3, giving 9, is also a factor. You can stop the video here to practice with 30. 30 goes the same way. It has 2 and 3, and 2 times 3 equals 6 as factors. Then pairing 2 and 5, and 2 times 5 equals 10. Next, 3 and 5, and 3 times 5 equals 15. Now you've said all the factors. Remember that usually a number has an even number of factors. There is one exception though. It's a perfect square. A perfect square is a square of integer. Let's take 9 for example. 9 is factorized as 3 times 3. Here, 3 is repeated. So, 3 is only counted once as a factor, while non-perfect squares such as 6, which is factorized 2 times 3, 2 factors. Now, let's compare the factors in the rows. These circled numbers are common factors of 18 and 30. As you can see, 6 is the largest, so the GCF is 6.
The way to find LCM is simpler. You just multiply 30 by 1, 2, 3, 4, 5 and so on. Accordingly, you get 30, 60, 90, 120, 150, and so on. You do the same with 42, and you get 42, 84, 126, 168, 210, 252, and so on. Then try to find the common multiple that first appears in both lists, that LCM. This is a simple and easy method, but it has one shortcoming. You don't know how many multiples you should get until you find the LCM. So, for finding GCL and LCM much more efficiently, you can now take advantage of prime factorization. The process is simple. For GCL, you first prime factorize the numbers. We use the same example of 18 and 30 here. You have already learned how to find the prime factors. 18 is 2 times 2 times 3. 30 is 2 times 3 times 5. Then you find prime factors that each number has in common, which is 2 times 3, and 2 times 3 is 6, so the GCL is 6. Now, let's find the LCM of 30 and 42. The first step in the process is the same. You factorize the numbers into prime factors. LCM is made by multiplying every prime factor that appears in either number. We take each prime factor the greatest number of times it appears in any of the numbers. It's easier to lay out the factors as shown. 30 is missing 7, and 42 is missing 5. In other words, we can find the least common multiple by multiplying all the prime factors that are missing from one number or the other. Then you multiply 30 by 7 and 42 by 3. That equals to 2 times 3 times 5 times 7, which is 210. So you can say the LCM is 210. Now let's practice finding both the GCL and the LCM of the following numbers. First, 12 and 20. 12 is 2 times 2 times 3, and 20, 2 times 2 times 5. So, the GCL is 2 times 2, which is 4. As for the LCM, 12 is missing a 5, whereas 20 is missing a 3. Including both factors, the LCM is 2 times 3 times 3 times 5, which equals to 60. So the LCM is 60. You can do the prime factorization the same way with any other numbers. Let's see 24 and 36. If you are okay with elementary school level calculation, you can tell the GCL immediately. However, it is a good idea to factorize them to check if it's correct. 24 is 2 cubed times 3, and 36, 2 squared times 3 squared. Be careful, 2 squared times 3 equals 12 is the GCF, not 2 times 3. You also need to be careful when you try to find missing multiples for the LCM. 72 is the LCM here. What about 42 and 60 say? It's still the same. The GCL is 21. Including the missing factor from each other, we get the LCM, which is 126. Today's final question is this. Find the GCL and the LCM of three numbers, 12, 18, and 20. All you have to do is the same. First you prime factorize each number. Then you find the common factor, which is 2 in this case. You might think it's 4 as you can see 2 squared in the prime factorization of 12 and 20. But it's not common with 18. So, the DCF is 2. It's all the same with LCM. But you have to be careful when you find the LCM. If you think of all the factors that are missing from one another, it can be complicated. I recommend that you focus on one number and simply multiply the numbers of other numbers that aren't shared with it. So, 2 times 2 times 3 times 3 times 5, which is 180. Like this. No matter how many numbers you are given, you can find the GCF and the LCM using prime factorization. This is the end of the section. If you can do this, you can factor out the greatest common factor from the expression to simplify the calculation. So try to get used to it.